With Karthik Rao, CEO of SignalFX, to talk about microservices and managing applications and monitoring everything so the trains keep running on time. Good to see you. Thanks for joining us.
Thanks, Larry. Great to be on.
So walk me through what SignalFX does and how we sort of get a handle on the microservices movement.
Sure. SignalFX is a monitoring solution for operators of cloud applications. I'll give you a little bit of history because it might frame our unique approach to solving this problem. Our technical team, my co-founder, our chief architect, our chief technology officer, were all at Facebook back in the mid-2000s when Facebook had their famous move fast and break things culture, where an intern could show up at the first day of work and push code out on the Facebook platform. And they just had a very unique approach to software development and software architecture. A handful of companies at the time, like Google and Facebook, were doing this, where instead of having this big giant software development project where you'd have hundreds of engineers working on something that would get released once or twice a year, you broke up your application into smaller, what today people call microservices, and you allow each of these teams to move independently and push code out very aggressively. And that just requires a fundamentally different approach to systems management and monitoring. And so our team was responsible for building the monitoring and observation technologies to make sure that Facebook could move fast without breaking things, and built a homegrown system there that ended up becoming hugely popular and is still in use today by Facebook, massively scaled out. And we asked ourselves a question about 6 years ago, is this a path that the rest of the world is going to be on, as cloud was just beginning to take its shape? And we came to the conclusion, yes, it would be. And we started SignalFX to take the lessons learned that we had at Facebook and bring it to the rest of the world.
So how much is microservices and this approach caught on into most enterprises? I mean, I know there's tons of talk about Kubernetes. There's a bunch of talk about Docker and containers. Where would you put us in sort of this migration to microservices?
Well, I would say it's less about enterprise and tech companies. I would say it's more, for us, the demarcation line is, did you start building new applications after 2013 or prior to 2013? Because Docker launched in 2013. It was one of the key enabling technologies with containers to kind of separate the underlying runtime of the operating system from the application environment that a developer could build and manage in their own environment and push directly into production environment. So when Docker became generally available or launched as an open source project, within a couple of years, we just saw a tremendous uptake in Docker. And if you look at any company, whether it's a big enterprise or whether it's a tech company, we see lots of tech companies whose applications were built pre-2013 that are monoliths. And they're looking at, how do we modernize these into microservices? And they're going through a very similar kind of a transformation that, big companies are when they're lifting and shifting their apps and thinking about how to modernize those. We see enterprises who are building digital applications post 2013. They've had these digital initiatives going for several years now, building direct to consumer apps that are containerized from the very get-go, because that's the de facto architecture. Now, in general, across the industry, I would say we're still early days, right? The vast majority of applications are still your classic monoliths, but I would say we see, 80+% of new application development is in the form of microservices and containerized. At different levels of sophistication, right? Some are just containerized, some are using the full frameworks.
So what are some of the challenges monitoring these applications relative to other software?
I would say there are two fundamental challenges. One is you create substantially more churn in the environment. So one of the big appeals of using microservices and containers is, instead of updating your existing software with a new package, you're effectively blowing out all your old containers and pushing out new ones. Containers give developers a lot of flexibility to push code directly out into a production environment. And typically the way they do that is they tear down the old ones and they bring up new ones. So, for example, we have some of our web scale customers doing daily code pushes where they will replace tens of thousands of containers every day with tens of thousands of new containers. It's just how they do code pushes. So effectively, they're turning over their entire server fleet on a daily basis. So over the course of a year, they still have on average, 10,000, 20,000, 30,000 systems that are producing monitoring data. But if you look at it from the perspective of a monitoring solution, it's actually 10,000, 20,000, 30,000 times 365 or 300 or however many code pushes they're doing. So that churn is what we call it, is a substantial new challenge in the monitoring world, because you've got to be able to handle the elasticity of today's environment. The second thing that's fundamentally different and challenging is when people move to microservices, they tend to have individual teams managing each individual microservice. And when you have a problem, when you're making a call into an application, oftentimes you're hitting dozens or hundreds of these microservices. Like if you go to the Amazon.com webpage and you search for a particular item you're shopping for, you could be hitting dozens of microservices behind the scenes. And if you have a problem, how do you pin the tail on the donkey and know exactly which service is the one that's creating the problem, especially when you're crossing so many organizational boundaries, because each of those services is managed by a different team. So that's become one of the largest challenges of monitoring in a microservices world, because when you have a problem, being able to isolate it quickly across organizational boundaries becomes very challenging. So you really do need more of an assisted, analytics-driven, call it AI-driven approach to help you pinpoint those issues very precisely across a very dynamic, fast-changing environment. So those are the two. There's a problem of scale with churn, and then there's a problem of being able to isolate problems quickly when you have such a diverse environment.
And I guess the older approaches would be, agents. They would monitor network data flying around. Is that a challenge when you have, infrastructure and applications that are, churning with all the containers that get tossed out?
Yeah, absolutely. Right. I mean, if you have a deployment model where you have to have an agent to discover information about systems, that doesn't always work in today's environments, right? I mean, if you're using a serverless environment, a Lambda or a function architecture, you don't have access to the underlying operating system. You can't deploy an agent. So the way you collect data has to be a lot more flexible. What we're finding is, historically, the monitoring world, the vendors, third-party vendors, provided value by selling you a proprietary agent. And that agent would go and collect information about a physical device, a storage device or a network device, or a proprietary application like an Oracle database. And that was their value. But in today's world, more and more of the software that you're running is open source, or it's built by your own team. And so you don't need to rely on a third-party vendor as much to collect the data, because it's already there. The challenge has really shifted to how do you make sense of all of this data in an intelligent way. And so that's a really significant shift that has been emerging over the last 5 to 7 years.
Well, what's the role of the cloud in this and the public infrastructure providers in terms of either providing data? Are they competition in some areas? Where do they fit into this?
The cloud vendors they're data providers, right? So you have to look at the cloud vendors at various levels in the stack, right? I mean, the core infrastructure as a service providers, they all provide a certain level of visibility into their cloud services, as you would expect if you're paying as much as you are for them. They provide APIs to collect all that data into an ecosystem of third-party solutions like SignalFx. If you're up the stack and you're using, database as a service or any of these other platform as a service capabilities, they also provide a number of, instrumentation to the third-party ecosystem. So the way we see it is they provide a certain amount of data necessary to get visibility into these services. They have a baseline set of capabilities that they provide their customers. But in our experience, most of the mid to larger size companies prefer to have an independent third-party vendor that provides the aggregation and alerting and monitoring layer across all of the different cloud providers, because more and more so they want to be multi-cloud, not single-sourced on a single cloud vendor. And in general, it's very similar to what had happened in the previous generations of technology, in that you want your monitoring solution to be an independent business process that you can maintain regardless of whether you decide to switch from one cloud provider to another. Just like 20 years ago, if you were an IBM shop and you decided to become an HP shop, you didn't want to change your monitoring technologies. The same thing applies today. It's just substitute cloud for proprietary hardware.
Okay. What data sources are most valuable when you're monitoring applications?
Well, we collect data across the full stack. Obviously, it's important to have data at every layer. The application data tends to be the most interesting to most of our customers, but they do need to correlate it against the underlying infrastructure data as well. Because if you want to, as I used the phrase before, pin the tail on the donkey and figure out where a problem is, problems emerge at all layers of the stack. Whether it's a disk failure on a cloud instance or a network congestion issue between two services, or it could be a middleware issue with an open source database or application, any kind of middleware that you're running, or it could be your own code. So collecting data across the entire stack becomes more and more important. What we found is having data across multiple domains consolidated into one solution that can do correlation and analysis across all the different stacks becomes very important, precisely because oftentimes, the issue could be anywhere in the stack.
Okay. You guys have made a big thing of streaming data and to monitor microservices and all that. What are the biggest challenges in finding, the actual signal versus the noise?
That is the central issue today in understanding, production systems, because there's just so much data, and if you're just running on a big Oracle Exadata appliance, like you just weren't generating as much data. And so it was a lot easier to find the issues. That's in today's environments, you have, 10x, 100x the number of systems, you've got 1000x the volume of change with DevOps methodologies. So you really need to have an analytics driven approach to understanding what's different or what's changed. And historically, the way most people did any kind of analytics on monitoring data was fairly simple. You would look at averages, you would run queries every 5 minutes to see if something has changed. But in today's environment, you need to do more sophisticated analysis, and you need to be able to do that very quickly in seconds. So the reason this is important is, we have a lot of enterprise customers in the retail space, for example, or in the media space, and they have events, right? They have a product launch, limited edition, and every retail company we talk to, they're focused on direct to consumer, whether it's the manufacturer of the original good, or even retailers. And those are very spiky workloads. And when you do a limited edition launch, you could generate, or sell out of your entire stock in 3 or 4 minutes. And a lot of these companies are leveraging these modern technologies to support bursting up capacity to support these launches. And if your monitoring system is only detecting issues in a few minutes, call it 3 or 4 minutes, your launch is basically over by the time you have any visibility. So you really need to detect these issues within seconds of a pattern emerging, and then ideally drive automated remediation, leveraging all of the capabilities that today's frameworks provide you. You can auto scale, you can auto rollback, you can do a lot of things that you couldn't do before, because the infrastructure is so much more, and the applications are so much more automatable. And so when we started SignalFX, we looked at all the different technology approaches to, building an analytics-based monitoring system. And at the time, the way everyone was doing it was they take all the data, dump it in a database, and then run queries against it and try to build more and more sophisticated analytics. The problem is, the more sophisticated your analytics got, or the larger your data sets, it would just take longer and longer and longer. And that wasn't acceptable. And so we built a streaming analytics approach that is effectively in real time. We're looking at the incremental changes, adjusting our algorithms based on the incremental data. And we're able to be much more event-driven and much more real-time in detecting these issues, where within seconds of something happening, we can flag it and help our customers drive any auto remediation that they desire.
What about Facebook's infrastructure in the time you were there applies to broader enterprises these days?
Well, I think the common themes, what companies like Facebook and Google did in the 2000s is they decouple, they focused on speed rather than efficiency and process. So the way most software development had been done for 20 or 30 years before was, you have these huge teams working on these big software projects, and you design your process to de-risk any potential for a negative change, right? You just want to reduce risk as much as possible, be as efficient as possible. What Google and Facebook did was they said, look, we're going to embrace the risk. That's the only way you can move quickly, right? If you're going to be paranoid about risk and get tons of teams involved and have all of this rigorous process, you're never going to release software very quickly. So what they did instead was they designed their development teams, they designed their development methodologies, they designed all of their operational tooling such that each team could move independently, they could move very quickly, and if you introduced a problem, you minimize its impact to be as small as possible so it doesn't bring down all of Google or all of Facebook. And you design it in such a way that you can roll back the changes very quickly and get back into a good state. So that was a fundamental change in thinking around development methodology. That today that's the central principle behind DevOps, right? It's you design all of your applications and your development methodologies so that you break apps, big, complex apps, into much smaller components that individual teams can manage independently. You design your software deployment so that you can, continuously integrate changes, push it out, and then if you have a problem, you can roll it back very quickly. You need monitoring systems that can detect these changes instantaneously. But the entire workflow has to adapt to support speed. And that was basically what companies like Facebook and Google pioneered. And when you look at enterprises, that's entirely what they're focused on right now, right? They're focused on speed. They want to be able to compete against all of the tech companies here, which are overtaking traditional businesses in every vertical. So it doesn't matter what business you're in, you're facing disruption from a technology company, unless you also acquire and develop these modern software development and deployment practices.
Right. Okay. Great. Thanks for joining us today.
No, thank you very much, Larry. Great to be on.